All right, hello everyone, and thank you all for joining today. My name is Lauren Gibel, and I am Director of the Growth Management Office for Cox Edge. And my team manages business operations along with several chief of staff responsibilities reporting up to our general manager. But at the end of the day, what I am focused on is determining how Cox Edge can most effectively bring value to our Edge customers. So that said, welcome to the very first episode of our new webinar series titled Edge 101. In this series, we'll be focused on sharing the foundational information with you all on the topics of edge networks and edge computing. Specifically, what we'll be covering is how we got here, the surprising and different ways that edge use cases are developing, and where edge computing is heading. So to kick off the series today, I'll be sharing the history of Edge in 3 different stories. So the first is how we got here. The second is what's happening today. And then the third is our best hypothesis on where we think this is all heading. So let's kick things off with how we got to where we are. So one second on the slide change. There we go. All right, so we started on the left-hand side here with computers that took up entire rooms. And as compute has evolved, we now have computers that are so small, in some cases, we can't even see them. We also went from enormous power usage to things like RFID tags that sometimes don't even require power. So every day we're surrounded by more computers, and specifically more connected computers than we even realize. We are driving past, walking past, or even standing next to a massive amount of computing and storage all the time. And I say this to bring light to something that you probably already know is just how important computers are to our everyday lives and that they are everywhere. And the growth of this kind of local, available everywhere, all the time computing will not be slowing down anytime soon. And this is because there has been an explosion of data, not only on the sheer amount of data that we're generating from all of these connected devices, but also what we can do with that data and the value that we can extract for human experiences. And the needs of applications and new emerging technologies that produce and process this data are ever changing, and it ends up necessitating new infrastructure needs, which you'll see through this evolution. And that's what's driven us to where we are today. Businesses have a need for decentralized compute that can quickly and efficiently help us derive value from the mountains of data that these new applications are generating. So let's talk about what's happening now. And where we'll start is by talking about the cloud. So at the highest level, compute is a term that's used to reference processing power, storage, and other resources that are required to complete a task for a program or application. And cloud computing is taking that processing and storage off of a local device and letting it reside on the cloud, which is essentially just a cluster of servers sitting in a giant data center. A great example of how applications use cloud computing are the Microsoft Office applications that a lot of you are probably using every day. As you've noticed, you can access your documents from any device, and this is because the storage function is happening in the cloud instead of on your desktop or laptop. And when you're using these applications and sending information back and forth, that's leveraging compute in those cloud data centers. And these data centers that enable the cloud can be run by service providers like Google, Amazon, Cox, or managed privately by companies for their applications. And the cloud is great for some needs. However, there are specific use cases where the centralized aspect of the cloud hinders applications' ability to do what it needs to do. And this is especially prevalent when speed is of importance. And this is where edge computing comes into play. So the easiest way to understand edge computing is to compare it to the cloud and how they differ. So edge computing is the next evolution of cloud computing, and it's required to support lots of emerging technologies such as virtual reality, cloud gaming, IoT, just to name a few. And something important to note is that edge is not going to replace cloud computing. It's actually the ideal complement to the cloud. So edge can work in conjunction with the cloud to add versatility to a business's network. So on the left-hand side of the screen, you have traditional cloud computing, which consists of these large centralized data centers. And as a result, the compute is not always taking place close to the end user or the device. And what I mean by that is, for example, a mobile app that's hosted in a cloud data center in Virginia may have app users located in Miami. And there's a lot of physical distance between the app user in Miami and where the app is hosted and processing is taking place in Virginia. And this distance creates latency. And since data can only travel so fast, it can cause numerous downstream implications. So you'll see I have noted here, with the cloud, you're looking at response times of about 60 milliseconds. And we do have use cases where 100 plus milliseconds of latency will suffice, such as certain types of video streaming, which are well suited for the cloud. There are also non-time sensitive data processing needs that companies may have, where this large centralized compute is optimal for what they're trying to accomplish. And then with edge computing on the right-hand side of the screen, instead of having a few data centers, potentially hundreds of miles away from where data is collected and created, the edge network data center might be only a mile away or even closer. And that's because an edge network uses a lot of small data centers that each service a small area. So instead of a handful of big data centers, you could have hundreds or even thousands of smaller ones. And this lesser physical distance can result in a much quicker network response time, in some cases 15 milliseconds or less. And for use cases that require this ultra low latency, the cloud will not suffice. Only edge can enable these experiences. So there's a few reasons why these difference of milliseconds matter when comparing cloud and edge. So one is around visual perception. It takes around 13 milliseconds for humans to process an incoming visual. So for something to be perceived as real time, you need to be as close to that 13 milliseconds processing time as possible. As this latency metric increases and we start to get closer to, say, 100 milliseconds, it degrades our processing ability and we become very conscious that input has slowed. We then have to adapt our perception by anticipating what's about to happen instead of simply reacting to it. And from a user perspective, the difference is pretty noticeable. Back to the augmented reality use case, if you're overlaying computer-generated images with the real world, you need those both to appear in real time for that user experience to be enjoyable. All right, so taking this down a level further, there are also multiple types of edge computing. And when describing the various types, we're always speaking in reference to the proximity to the cloud data center. And this then gives us the concept of far edge and near edge. So far edge takes us as close to the consumer as you can get. It's the infrastructure that's deployed farthest from the cloud data center and hence closest to the users. And this type of edge is typically accomplished through mobile edge, device edge, and sensor edge. And far edge computing can be deployed in enterprises, factories, shopping malls, as I mentioned, everywhere earlier in the discussion. So the apps running on this infrastructure need high throughput, scalability, low latency, which is great for use cases like augmented and virtual reality and video gaming, just to name a few. And then you have near edge, which is computing infrastructure deployed between the cloud data centers and the far edge. It puts the compute resources near the data, but might not be necessarily right at the data. And this is a good middle ground between a cloud data center located far away and the edge data center situated at the source with limited resources. And where Cox plays is in the space of network edge. So we have an inherent advantage by sitting closest to the end user from a network delivery perspective. So scaling numerous devices at the far edge in a cost-effective manner can oftentimes present challenges. So this is where network edge can be particularly useful, especially in cases where it's too costly or complicated to put compute on premise. However, in these cases, while it may be costly and complicated, you still need that responsiveness because the cloud is too distant. So now that you guys have a general understanding of edge computing and the different types, how do you know when edge is needed versus the cloud or other compute types? So one of the key indicators is the type of application running on the compute. So if this application involves, for example, online gaming or anything where latency negatively impacts the user experience, Edge will be able to deliver optimal performance. Another consideration is security and privacy. In today's digital world, there are often concerns about data security and data privacy, and edge computing actually allows for local processing and analysis of that sensitive data. And therefore, it reduces the risk of data breaches and other potential security incidents that can occur when that data is being transmitted to the cloud otherwise. And then the last consideration I'll highlight is cost. Centralized computing often requires large amounts of data to be transmitted to a centralized location. And this can be challenging in situations where network bandwidth is limited or it's expensive. And edge computing can help reduce that bandwidth by processing data locally and transmitting only the most relative data back to the cloud. And what business doesn't love to save money? So a few things that I want to highlight just as a key takeaway to dig a bit further into far edge, near edge, and the cloud. Um, this chart, I think, does a great job at highlighting the different attributes and what dimensions you need to consider when making that decision. So on the y-axis, you have considerations around latency, storage capacity, compute power. And when these needs are high, having compute sit farther away from the consumer provides an optimal solution. And this is both from a technology and a cost perspective. As you start to have needs for lower latency, lower storage capacity, you move into the realm of relying upon far and near edge to meet your needs. And the closer you can get to the end user, the lower you can achieve on these y-axis considerations. All right, so I wanted to highlight a use case that's relevant for a few companies that you all are likely very familiar with. And if you're like me, one of them is providing daily package deliveries to your household. Um, so if you think about what e-commerce companies like Amazon and Google are concerned with, it is a seamless user experience, and that is because it's helping drive their revenue. Users abandon a web page has serious implications on sales conversions and ad revenue. And there have been a few different reports from some of these e-commerce giants about how some of these seemingly insignificant metrics have a very significant impact on their business. Amazon reported that just one additional second of page load time could cost them an estimated $1.6 billion in lost sales per year, which is huge. Google calculated that by slowing its search results by just a quarter of a second, they could lose up to 8 million searches per day, meaning they would serve up millions of less advertisements as a result. And these kind of metrics are where Edge can bring value in the e-commerce space. And this is because Edge can help improve response times and provide optimal page load experiences. So tomorrow is coming. Where do we and others think that Edge is headed? Well, our hypothesis on the expected growth of edge computing comes from that we're already seeing today and are expected to compound in the coming years. IoT Analytics predicts that by 2030, so just 7 years from now, over 75% of all devices will be IoT devices. And this ties back to what I shared earlier in the presentation about just the sheer volume of connected devices that we're surrounded by every day, and in turn, the data that they're generating. And these IoT devices oftentimes can't rely on the cloud alone to perform. And if you think about the possibilities for retail companies, specifically around leveraging technology to operate more efficiently, analysts predict that US retailers could save over $37 billion each year by implementing cashierless technology. And lastly, we can tie this back to what it means for the bottom line for companies. We often see reports that over 90% of companies are investing in data-intensive use cases, and lowering the cost to manage these can help companies leverage this data in a more profitable way. So to wrap up my presentation for today, I wanted to provide a few insights into how Edge's capabilities are required across a multitude of industries. Because of the versatility of edge computing, companies of all types can take advantage of what local compute enables. And I'll highlight a few examples. So one, which I've mentioned a few times now, is in the gaming space. So players compete with one another in their own respective homes, and any degradation of service means the other player has an unfair advantage. If you've done online gaming before, you know how frustrating lag can be and how it can impact your performance. In the retail space, cashierless transactions will open up the door for failed checkouts. And so, depending on when notification is sent to a store manager, it could mean the difference between recovering those goods or having lost revenue. And lastly, another industry that will benefit significantly from Edge is manufacturing with its shift to Industry 4.0. And that they're able to then use AI to control robotics on the assembly line, which greatly helps their efficiency. And these are just to name a few. We are still in the early stages of Edge adoption, and it's very exciting for us at Cox Edge to hear new stories every day about how companies are harnessing the power of Edge compute to drive really meaningful business outcomes. So, with that said, let's now pivot to some questions that came in ahead of the webinar. So, first up, what issues do customers usually run into when they move to the Edge? So there's a few concerns that we typically hear from customers when we're discussing migrating their existing workloads to our Edge. So the first is just around the effort it's going to take to migrate their workloads from their existing solution, such as public cloud, to the Edge. And the complexity here really varies just based on the state of the applications. So it can range from a more straightforward lift and shift approach where the workloads can be moved as is to the cloud, or excuse me, from the cloud. And then it can also be as involved as entire applications needing to be re-architected to take advantage of cloud technologies. Good news, there are a lot of tools out there that can help make this transition a lot easier. And if you don't have that in-house expertise in this area, it's always a great first step to reach out to your Edge cloud service provider of choice, such as Cox Edge, and talk to their experts that do this kind of thing day in and day out. All right, so second question we have on here. Does using Edge mean replacing public cloud with Edge, or is it a hybrid setup? So good question. I mentioned this a bit earlier, but just a great opportunity to drive this message home. Most companies are not simply using one or another. They're taking a hybrid approach. And this is because there are certain use cases where the cloud is still the optimal choice. So the best way to think about Edge is really as a complement to the cloud instead of thinking about it as an inevitable replacement. It's likely that we'll continue to have a need for centralized processing for some time and don't see that going away anytime soon. The last thing I'll add is just you can also think about edge computing as a way of covering for some of the shortcomings of the cloud. And this is where that hybrid concept is not only possible, but recommended and typically critical to continue success with the business applications. All right. And third question, what cases do you see where AI and edge can mix well? So, um, I touched a little bit on the manufacturing concept. I think this is a great use case because you can actually leverage AI in a manufacturing plant to make it a safer environment for the workers. So while having both workers and robotics present, there can be proactive monitoring that's in place so that you can potentially catch a catastrophic incident before it happens. And you can also have more real-time alerts so that when something does come up that needs to be addressed, it's not having any kind of delay and making its way to the right people. Another great use case is with the retail use case, like I mentioned earlier. So there are a lot of really cool things that we're starting to see come out in the retail space about being able to leverage AI for making recommendations, for being able to provide shoppers with an idea of what that purchase could look like in their home or on them before they make the purchase, and then also making smart recommendations and leveraging lots of historical information to be able to provide smarter recommendations to customers that are a little bit more targeted versus the generic that we sometimes experience when we're online shopping. So, and I think that's it for the questions that I'm seeing coming in. So, just want to thank you all for joining me today. It was great to be able to share with you all about some of the foundational information for edge computing. And we try to respect everyone's time. So, wanted to keep this short and just a quick bite of information for you all. So thanks again for joining, and hope you all have a great rest of the day.